In southern Oregon, in the United States, there is a lake so deep and so blue that the indigenous Klamath peoples were afraid to look at it. Crater Lake, at nearly 2,000 feet deep, about 592 meters, is the deepest lake in the United States. But what most people don't know is that this lake was not formed by nature in a peaceful way. It is the result of one of the greatest volcanic catastrophes in North America in the last 500,000 years. We are talking about the collapse of Mount Mazama, a volcano that once stood nearly 12,140 feet tall, about 3,700 meters, roughly the size of Mount Fuji in Japan, and that simply collapsed on itself. And look, when I started researching this story and connecting it with what is happening right now far off the coast of Oregon, I was genuinely impressed. Because about 298 miles, roughly 480 kilometers off the coast, hidden beneath nearly a mile, about 1.5 kilometers, of Pacific Ocean water, the most active submarine volcano in the Northeast Pacific is showing signs that scientists monitor 24 hours a day. This is the Axial Volcano, or Axial Seamount. And what I am about to tell you puts these two Oregon volcanoes side by side in a way that might change how you see the power that exists beneath our feet. Think about this with me for a second. 7,700 years ago, Mount Mazama was an imposing giant in southern Oregon. It was part of the Cascade volcanic arc, the same chain of volcanoes that includes Mount Rainier and Mount St. Helens. Mazama was not a simple volcano. It was a complex of multiple overlapping cones that formed over nearly 500,000 years. According to the United States Geological Survey, the USGS, the first eruptions that gave rise to Mazama began around 420,000 years ago, first building Mount Scott, which today is the highest point on the caldera rim. But what really matters in our story begins about 30,000 years before the collapse. At that time, Mazama started to change its behavior. The eruptions became increasingly explosive, producing silica-rich lavas that geologists call rhyodacite, with about 70% silica. You know what that means? The more silica, the more viscous and more explosive the magma is. It is like, you know the difference between putting water and putting honey in a pressure pipe? With water, the pressure escapes easily, but with honey, the pressure builds up until everything explodes. That is exactly what happened beneath Mazama over thousands of years. An enormous reservoir of highly explosive magma accumulated deep underground. And when I say enormous, I'm talking about something around 12 cubic miles, approximately 50 cubic kilometers of magma. To give you an idea, that is 10 times the volume of the Mount St. Helens eruption in 1980. Oh, before I forget to mention, some weeks or perhaps months before the Great Eruption, there were signs. The Cleetwood lava flow on the north side of the volcano was produced so shortly before the collapse that when the caldera formed, that lava was still hot enough to flow back into the hole. That shows how fast everything happened. And then the day came. Exactly 7,700 years ago, a column of pumice and ash erupted from a single vent on the northeast side of Mazama. According to the USGS, this column reached about 31 miles in height, approximately 50 kilometers, meaning nearly the edge of space. The winds carried the ash across the entire Pacific Northwest, and even into parts of southern Canada. Mazama ash deposits have been found in 8 American states, 3 Canadian provinces, and even in ice cores in Greenland. The area covered by the ash was approximately 656,000 square miles, around 1.7 million square kilometers. That is larger than the entire Brazilian legal Amazon. Let me grab my water here before continuing, because this part gives you chills. As more and more magma was expelled, the volcano simply could not support its own weight. Circular fractures opened around the peak, and pyroclastic flows, which are superheated avalanches of gas and rock that can reach hundreds of degrees, rushed down all sides of the mountain. According to studies published by geologist Charles Bacon of the USGS, the total eruptive volume reached 42 cubic miles, 176 cubic kilometers, of material, including pumice, ignimbrites, and tephra. The collapse reduced Mazama's height by nearly 5,250 feet, about 1,600 meters, leaving a depression 5 by 6.2 miles, 8 by 10 kilometers, in diameter and about 3,940 feet, 1,200 meters, deep. The aerosols released by the eruption reduced global temperatures in the northern hemisphere by between 1.1 and 1.3 degrees Fahrenheit, 0.6 to 0.7 degrees Celsius, for up to 3 years. According to peer-reviewed scientific studies, this climate impact may have been even greater than that of the Mount Tambora eruption in 1815, the one that caused the famous year without a summer. Today, rain and snowmelt have filled the caldera, forming the deepest lake in the United States. But geologists know that Mazama is not extinct, merely dormant. And the USGS considers this volcano one of the most hazardous in the United States. Now, shift the scene with me. leave dry land and dive 298 miles, about 480 kilometers, to the west of the Oregon coast into the middle of the Pacific Ocean. There, about 4,600 feet, roughly 1,400 meters, below the surface of the water, sits the Axial Volcano, or Axial Seamount. And here I need to be honest with you because this is a crucial point. When I started researching, I wanted to know if the Axial could repeat something similar to Mazama. And the scientists' answer is clear: no, and here is why. Mount Mazama was a stratovolcano in a volcanic arc, fed by highly viscous and explosive rhyodacite magma, the result of the Juan de Fuca plate subducting beneath the North American plate. The Axial Volcano is a submarine shield volcano located on a mid-ocean ridge, the Juan de Fuca Ridge, where the plates move apart, not collide. The magma at Axial is basaltic, thin fluid like ketchup compared to Mazama's honey. The eruptions at Axial produce lava flows that reshape the seafloor, not catastrophic explosions. William Wilcock, a marine geophysicist at the University of Washington, explained that it is like comparing a pot of thin tomato sauce, gently bubbling with a pot of thick sauce that bursts and splatters everywhere. But, and here is the important but, Axial has something fascinating in common with Mazama. Both possess calderas formed by the collapse of their magma chambers. The caldera at Axial measures 1.9 by 5 miles, 3 by 8 kilometers, with walls up to 492 feet, about 150 meters high. And what makes Axial so special for science is that it is the most monitored submarine volcano on the planet. According to Bill Chadwick, a researcher at Oregon State University, Axial erupted in 1998, 2011, and 2015. The prediction was that it would erupt in 2025. But in December of 2025, during the annual meeting of the American Geophysical Union, Chadwick updated the forecast to mid to late 2026. Currently, the seafloor inside the caldera is about 4 inches, roughly 10 centimeters, higher than it was before the 2015 eruption. But scientists estimate that another approximately 8 inches, about 20 centimeters, of inflation are still needed before the next eruption occurs. In August of 2025, Axial recorded as many as 2,000 tremors in a single day. The current hypothesis is that approximately 500 earthquakes per day, sustained along with rapid inflation, will be needed to trigger the eruption. And the good news, the great good news, is that even if Axial erupts tomorrow, there is no danger to people. Debbie Kelly, director of the Regional Cabled Array at the University of Washington, confirmed that the eruption will not generate tsunamis, will not affect the ocean surface, and the lava will simply reshape the seafloor. In fact, scientists plan to broadcast the eruption live for the first time in history, if it happens while the equipment is operational. So, what Mazama teaches us about Axial is not that we should be afraid, but rather that constant monitoring of volcanoes saves lives and advances science. Oregon carries in its territory and in its waters an extraordinary geological heritage, from the deepest lake in the country to the most closely watched submarine volcano in the world. And I promise to keep following every new piece of data that comes in. If you were as fascinated as I was by these forces that shape our planet, subscribe to the channel. Every week I bring content like this, always with verified data and official sources. Hit the notification bell so you don't miss anything. And if you know someone who needs to know these incredible geology stories, share this video. Knowledge transforms the way we see the world.